Using the James Webb Space Telescope, astronomers have observed a quasar with an immense, galaxy-killing wind blowing from a supermassive black hole in the distant universe. This is a significant leap in understanding how galaxies evolve and, ultimately, die. The quasar, known as J1007+2115, is so far away that we see it as it was just 700 million years after the Big Bang, offering us a glimpse into the very early universe. In this video, we'll explain what this discovery means, why it's so significant, and how it changes our understanding of the cosmos. This quasar is located a staggering 13.1 billion light-years away. What's truly fascinating is that we're observing it as it was just 700 million years after the Big Bang. This makes it one of the earliest quasars ever discovered, placing it in an era when the universe was only about 5% of its current age. But what exactly is a quasar? In simple terms, a quasar is a supermassive black hole that's actively feeding on the gas and dust surrounding it. As this material falls into the black hole, it forms what's called an accretion disk, which is a flattened, spiraling cloud of gas and dust. The gravitational forces at play in the accretion disk create friction, which heats the material to such extreme temperatures that it shines incredibly brightly. In fact, quasars are some of the brightest objects in the universe, outshining entire galaxies. Now, this quasar is producing a mighty galaxy-size wind. This wind is blowing gas and dust away from the galaxy at a staggering speed of 4.7 million miles per hour, 7.6 million kilometers per hour. To put that in perspective, that's more than 6,000 times the speed of sound. This wind stretches across 7,500 light-years. Imagine 25 solar systems lined up side by side, and you'll get a sense of just how vast this outflow is. One of the most impressive aspects of this wind is that it carries material equivalent to 300 suns away from the galaxy every year. This kind of power has profound implications for the galaxy itself, which we'll dive into now. So, what's the big deal about these quasar winds? Why should we care that this quasar is blowing out gas and dust at mind-blowing speeds? Well, the answer lies in the stars, or, more accurately, the lack of stars. You see, gas and dust are the essential building blocks for star formation. In galaxies like the Milky Way, stars are born in dense clouds of molecular gas. However, in the case of this quasar, the wind is essentially blowing away these star-forming materials. It's like a cosmic eviction notice. The galaxy is being stripped of the gas and dust it needs to birth new stars. Without these materials, the galaxy's ability to form stars grinds to a halt. This process is what we call quenching, and it's a critical factor in galaxy evolution. When a quasar wind quenches star formation, it effectively kills the galaxy's ability to produce new stars, turning it into what scientists call a dead galaxy. Over time, without new stars to fuel the galaxy's growth, it stops evolving and becomes stagnant. This quasar wind is a prime example of this process in action. Researchers believe that the wind is strong enough to deprive the galaxy of its star-forming material, and this could mean that the quasar's galaxy is no longer forming stars. It's likely that this galaxy will transition into a dead galaxy. Moreover, quasar winds are not limited to distant galaxies. Observations of nearby galaxies, such as NGC 1068, show that even in our cosmic backyard, supermassive black holes can generate molecular outflows that quench star formation. This reinforces the idea that black holes, whether in the early universe or today, are intimately connected to the life cycles of galaxies. Now that we've explored how these winds affect star formation, let's turn our attention to the black hole itself and what this discovery means for the growth of galaxies and black holes. In the case of J1007+2115, the wind is so mighty that it's actually cutting off the black hole's own food supply. Black holes grow by accreting gas and dust from their surroundings. But when the quasar wind pushes this material away, the black hole can no longer feed. This means that the growth of the supermassive black hole in this quasar may have been halted or severely slowed down. This is a common theme in studying active galactic nuclei, AGNs, which are powered by supermassive black holes. AGNs, like the one in this quasar, generate winds and outflows that regulate both the galaxy's evolution and the black hole's growth. By pushing away gas and dust, these winds limit the amount of material that the black hole can accrete, effectively capping its size. But this quasar is not alone in this behavior. In 2019, researchers studying the black hole at the center of galaxy M87, famously imaged by the Event Horizon Telescope, observed powerful outflows that similarly affected the surrounding galaxy. These jets and outflows are thought to influence the interstellar medium, much like the quasar winds in the quasar we are talking about. Also, in 2015, astronomers discovered the quasar SDDS-ACE, one of the brightest quasars ever found. This quasar also exhibited powerful winds, capable of suppressing star formation in its host galaxy. These findings suggest that quasar-driven winds are not unique to the one we discussed, but are part of a more significant cosmic phenomenon that has been affecting galaxies for billions of years.